Hello everyone, welcome to IMSC 685 MIS Logistic Regression Lecture 2. Let's go over to the class modules, and I want you to start download the Logistic Regression, the third notebook, and also download the Titanic Trend and Titanic Test data set along with it. So we're going to start talking about the logistic regression implementation using Python Jupyter Notebook. So let's start with the empty notebook, and we just start with some importing some of the library for now, and import NumPy as MP, import Matplotlib as PLT, and import Seaborn, which is also okay. And also, since I'm using Jupyter Notebook, and so Matplotlib is going to display inline. Okay, so that's this. The second, we're going to load the data from our directory. Make sure the data is in the same directory as your notebook. So here I'm trying to do a trend dataset equals to panda re CSV, and like that, similar like that. So I'm going to do actually Titanic trend CSV dataset. Okay, this is what we're going to do. All right, just have some mistyping. Titanic trend.csv, reading that, and then the next one we're going to do see how to all right, this is our data set so far, and so we see the first is a passenger ID, survival, yes or no, 0, 1, and the classes the passenger is in, and the name of the passenger, the gender, and the age. If this passenger has any sibling or spouse come along on board, or also the passenger has any parents or has any child dependents, also the ticket number, the fare passenger paying, which cabinet they are in, also which port they're embarked from. So let's do some basic so-called exploratory data analysis. Let's do using Seaborn first. I'm going to using a heat map. Okay, and so heat map, I'm going to see if the trend dataset. I'm going to ignore the null first. Okay, and also white tick is off. I'm going to not showing any white ticks. White ticks label. Okay. White tick label is equals to false, and then C bar I'm going to use with false. Also, I'm not going to be using color bar, and also I'm going to using a more visible color map called there it is. Okay, so let's take a look. Okay, this is a color map we have. Looks at this, there are two areas we have a missing value. The first one is the age of the passenger. It's about 20%. There are about 20% of missing value in the age process. With this amount of missing data, we probably can, as a numerical data also, so we can probably doing some kind of fill in, or call it imputation, to fill in some of the data. Also, there's a lot of missing data for the cabinet information, and there are too many of them. It's hard to recover the missing value, or using some other places to referring to that cabinet value. So we probably, in this case, we must just drop this data column, since they don't carry too much of the information in that case. So this is what we're going to do, and also let's do some other exploration first. Let me do the set style, and equals to, let's see, white grid. All right, and then do some counter plot. Sorry, plot. Okay, is x equals to what? Survive, since we are interested in the survive. And y equals to, let's do the hue, equals to the gender, and data using the trend data set. Okay, and palette, I'm going to using a palette is easier to distinguish. I'm going to using red and blue as my color palette. Okay, so let's take a look, and we will see that, and these are separate into male and female, and based on the survival rate. And let's take a look. It looks like the with this, and the male is largely non-survived, and as well the female has much more survival rate than the male passenger. So these are some data exploration you can actually look at, and also let's take a look also as the survival rate based on the a class of a cabinet they are in. Let's do it that way. So again, I'm going to style equals to y grid. Okay. Again, we're going to do the count plot. XE based on the survive again. Okay, and U equals to the P class. And also, and data set equals to the trend. And then this time I'm going to using a little bit different palette. Let's do rainbow. Okay, see if that will work. Okay, so these are the results we can use. So first we're using a complot and doing the survival, and the hue equals the P class. So we have 3 different classes. It's 1, 2, 3, and it looks like a majority of the unsurvived passenger on the 3rd class. Okay, and for the survival, and each one of the class are pretty much equal or consistent. And next we're going to do some exploratory for the age. Okay, again I'm going to do C1, but this time I'm going to using distribution plot on age column. So here I'm going to do on the trend data set, and actually based on age, let's do that. And I'm going to also drop, for example, drop the null value. Okay, drop the null value. Then I'm not gonna show any information for the detail description, and color equals to dark red, and let's do bin equals to 30. So 30 category bin. Let's take a look. Okay, let's do this, and you can see that actually the distribution you have also almost like a binomial type of thing. First is you see a category of passenger had less than 10, edge of a 10. These are the children group. Other than that, there's a bigger group, actually range from 20 to 40 range. So these are the passenger distribution. So if you're not really comfortable with using the seaborn, you can use also the panda histogram as well. Let's do this. See if we can easily do this with age. Okay, same thing. Histogram, and basically bins equals to 30. Let's do the same. Color equals to dark red as well. Also we do equals to 27. Let's see how that goes. Similar situation. So we can do either way for histogram plot. And and next we're going to explore the, for example, how many siblings and spouse is on board with this data set. Okay, so it's going to do complot, and again x equals to the sibling spouse column, and data equals to trend. I'm going to use very simple syntax for this, and you can see that majority of the passenger is on board alone, and this probably belongs to the P class 3, the third class passengers. And then a big group have one spouse or sibling on board, which is probably the couples, both of them on board. And then these are the distribution with the children's along with them. Okay. And next, we also want to take a look at how much the passenger pay for their ticket, how much they pay for their ticket. Let's do some basic plot. Again, we're using the trend data set, using fare, okay, column. All right. And do the histogram. Again, color, I'm going to using green. All right, color using green, and let's do 40 bins in this case, and make it a little bit bigger, figure size. Let's do with the A/4. Let's see how that's going to go. All right, I got an error. Okay, mistype right here. Very simple. So we see majority of the people paying almost nothing, very low, and then we can see that, and gradually there are some range between 20 to 100, and let's also look at that. Another way we can look at it a little bit more closely, we're going to using the cuff link. Okay, so let's do that. Import cuff link. As CF. And since we're going to do the offline, so cuff link, go offline. Otherwise, it will take a long time to plot. You probably already know that one. Let's do directly using the fare column and do iPlot using the kind equals to histogram. Okay, and beings equals to 40 again. Let's do the 40 again. Okay, and color also using with the green. Okay, so this is a similar plot using cufflink and Plotly. And the nice things about, you can see each one of the category, how many they are. And you can also, for example, zoom in to the portion you want. And so this is the good things about Plotly. But this is for other data exploratory to be run. So I'm going to temporarily stop this. Okay, we kind of finished the initial so-called exploratory data analysis. It's showing you how to visualize some of the data and using Seaborns and cufflink and the original Matplotlib. The next lecture, we're going to come back to discuss how we're going to clean the data and then make the data massage in a format is easily used for machine learning process, logistic regression. I'm going to conclude the current section.